Hi guys, so we're going to move on now in chapter 21 to part B of the chapter, which is talking about fuels. So this is going to be discussing how we get the fuels that we use. And the start point for that is crude oil, a very valuable and useful material. It provides us with fuels for transport and heating and for the manufacture of loads of other chemicals that we use every day. Now, it's not very useful itself in its most basic form. It's a thick black liquid with an unpleasant smell. It's a mixture of lots of other substances. And so, in order for it to be useful and to do all of these things, we need to separate it out into its useful parts. And these are called fractions. So they're called fractions. They're smaller parts of the whole original sample. We do this by a process called fractional distillation. Fractional for that reason, we're separating it out into its different parts. And distillation, as you might recognize from in class, is separating substances based on their boiling point. So this is what a fractionating column looks like. You need to be able to draw some sort of representation of this. So just quickly, before we go into too much detail, you have a furnace down here where the crude oil is brought in and heated up. It's then transferred as a vapor, so it's vaporized here into the fractionating column. And as the gases move up the column, the temperature decreases, decreasing temperature as you go up the column. That's very important. And these are the different fractions here out on the right. These are the different useful parts of the crude oil that we want to separate it out into. And then over here on the right, you've got the uses for each of these fractions, which you need to know as well. So we're going to flick back and forth between this slide and the next slide to go through the details of how this works. So step one here is that the crude oil is heated to high temperatures and fed into the fractionating tower or the fractionating column. So again, we have the furnace down here at a very high temperature, and that's going to vaporize the crude oil. And it's then passed into the fractionating column. Step two is the tower is kept at high temperatures at the bottom. So again, it's down nearer the furnace. So at the bottom, you've got your high temperatures. And as you go up the tower, there are trays present to collect the fractions. So these are the trays here sticking out of the column on the right. And they are where we're going to collect the different fractions. So it's written on top of it. So this tray, we're going to collect kerosene out of that. This tray, we're going to collect naphtha out of it. And step four, the temperature decreases as you ascend, as you go up the tower. So that's very important here. You have your higher temperature at the bottom, lower temperatures up at the top. You don't need to know these exact temperatures that are written on here. They're just for guidance at the moment. As the crude oil rises up the tower, the fractions will reach a temperature that is just below their boiling point, and it turns into a liquid, which is what's collected in the tray. So everything comes in as a gas down here. Anything with a very high boiling point is going to be coming off here at the lower levels, and anything with a lower boiling point, that's going to continue to travel up the column as a vapor until the molecules of a certain fraction reach that area that's just at about their boiling point. So kerosene, for example, the molecules of kerosene are going to come in, they're going to travel up the fractionating column, and when they get to this point, we know that this temperature is going to be around 200 degrees Celsius, and it's getting colder as it goes up. So as the molecules of kerosene get to this point, they're going to liquefy, they're going to condense into a liquid, and the liquid will run off out into this tray to be collected. Now, the important thing to note here is, what are these things? These are called bubble caps. So they're just like, if you have a bottle and you're putting the cap on it, but you don't tie it on tightly. That's what they are. They're loose caps here. And the reason for those is to slow down the rate that the vapor rises through the fractionating column. Obviously, you know, gas particles have lots of energy and they're going to spread out, they're going to disperse to fill up all available space. So if we didn't have something to slow the vapor down, a lot of the molecules, gas molecules that are injected down here, they're going to rise straight up to the top. And then we would have them condensing at different rates and it would be hard to collect them. So it slows down the rising of the vapor and it increases the contact time between the vapor and the liquid in the column. So we took kerosene as our example here. So it keeps the vapors here for a little bit longer than if it was to just keep going straight up if they weren't there. It keeps the vapors here a little bit longer so that more of this, to ensure that all the kerosene essentially condenses and becomes liquid to be collected here, that it doesn't travel further up the column. Point 6, the heavier just to say 0.5 there, that's the basis of what is happening here. So you do need to make sure that you have an understanding of step 5. You might want to rewind and go back and look into that a little bit further, listen again, or you might want to go to our Microsoft Teams page and ask a question. So feel free to pause and go do that now. Part 6 is telling you that the heavier hydrocarbons will condense first at the bottom and the lighter hydrocarbons will rise higher and condense higher up the tower. So if we look here, larger hydrocarbon molecules have a higher boiling point. So all of these down here with the higher boiling points, they're going to turn to a liquid much further down. So that's summarized over here in the yellow box for you. So down at the bottom, you've got high temperature, large molecules, high boiling point. And up at the top, you've got lighter fractions. So you've got smaller hydrocarbon molecules up here. They're going to stay vaporized. The vapor will rise up through the column, passing all of the trays until it gets to the right temperature. And where the temperature of the column is equal to the boiling point or below the boiling point, it's going to condense there and the liquid will be collected in the tray. So you don't need to know, again, like I said, you need to kind of have an understanding of this diagram. I think it would be helpful to draw it out into your notes. You don't need to know these exact temperatures, they're just there for guidance, but you do need to look at the uses of each of the fractions. So refinery gas or petroleum gas, that's LPG, liquefied petroleum gas, is what we use for cooking. Petrol, fuel for cars, same for diesel, fuels for buses, trucks, trains and cars. Again, I don't need to go through those with you. You don't need to go into any detail on it. You just need to know the uses. They're all broken down for you in the book as well. However, they are summarized quite nicely here for you on this table for you to have a look at. Before we finish up there, I just want to make this small note that to some of our substances, natural gas and petrol, a substance called methane thiol is added. Thiol there, just referencing the sulfur atom. That's added to natural gas and petrol to give it a stronger smell than what it has naturally. This is done for safety. So it's done for safety so that people can smell it if there's a spillage, and to help for the detection of leaks in industry if you have large quantities of it. So what I'll do, I'll stop there. This is your summary that you can have a look at. Any questions that you have, pop over to the post I made on the Microsoft Teams page and ask any questions there. If you don't have questions, that's fine. Can I still ask that if you're doing this now that you just let me know there that you have this video finished? That would be great.